It's 4.1. We're starting our quadratic unit. We've got this unit and one more unit, if I remember right, until the end of the semester. So both of the units are quadratics. The first unit, which we're in now, is graphing, and then the second unit that we'll finish is solving quadratics. So they're both chapter 4, but I have them in two different units. So this is graphing in vertex form. So there's two different forms for quadratics. The vertex form is this A, H, and K thing, which I think is the easiest form because it quickly tells you where you're going to graph the graph. The other one is standard form. So vertex form looks like this. And standard form looks like this. This is the one we're dealing with today. And it's actually the easier one when we go to graph. Probably Thursday, we start standard form, which is a little more involved to graph. So let's go ahead and talk about what a quadratic graph is. The original unshifted quadratic graph looks like this. It has what we call a vertex at 0, 0, and is a smiley face. This is called a parabola. So this shape is going to be the shape of all of our graphs for this unit. Any quadratic graph, anytime you have an x squared, it looks like that. But it won't be necessarily in that spot, or it could be flipped down, depending on the shifting of the graph. And that's what we're going to learn today, is the shifting. This is the shape, that's the name. This is the parent function, or the original graph every time you go to graph. Okay?
So y is x squared.
Y equals x squared is a parabola, is the unshifted parent function of all the quadratics. Okay?
Yeah.
So with that, let's go. Okay, let's talk about A, H, and K. I want you to bear with me because it may not make sense. I'm going to rewrite this so we can reference it. But like I said, A, H, and K mean the same thing for every single function. Just all the functions will have different shapes. So let's start with H because it's one of the easier ones, but it's one of the most important ones. H, this number inside with the X, is always going to tell you where you're going to move your vertex left or right. So H tells us left or right. And H is important because we do the opposite of whatever it is. Just bear with me, write it down because I've got 4 examples to show you. By the end, you'll feel good about it. So H tells you left or right, but you have to look at the opposite sign. So if it's x minus 4, that takes you to the right 4. If it's x plus 4, that takes you to the left 4.
So right now, since it's minus, that's plus. Yes.
This would be a positive shift, yes. Yes. K. K. Okay, K.
K.
If H tells you left or right, what does your gut tell you K is going to do? Up or down. Not flipping it up or down, just moving it up or down. This is going to tell you if you move your vertex up or down, and you look at the same sign.
So it's like that old stuff.
So if it's plus, it goes up, and if it's...
Correct. So this is all the shift of the vertex that started out at 0, 0. So the H on the inside is going to tell us where we're going to move that vertex left or right. And the K on the outside is going to tell us where we're moving that vertex up and down to get your new vertex. Okay? So A is kind of important, and it gives us 2 things, but A sometimes is a little confusing until we start using it. The easiest part of A, the first thing it tells us is if it is a smiley face or if it is a frowny face. So if A is a positive number, it's a normal parabola that goes up. If A is a negative number, it flips over the x-axis and it becomes upside down or a frowny face. So that's the first thing A tells you, is if it's a normal or if it's flipped down and a frowny face. The other thing A tells us is if the graph is wider or narrower. And all I want you to write down for this right now, and I'll show you once we use it, I want you to think of it like slope, even though it's not a slope. I just want you to think of it for now like slope. Now, we kind of did this with
I was gonna say.
absolute values,
Very simple.
okay? And now, so all of that, so that kind of proves my point. Every function that we do has a vertex form. So the h, the k, and the a, I didn't even think about absolute value. The a, the h, the a, whatever these are, h, k, and a, all mean the same thing, okay? Just the shape of the graph is going to be different. So our graph that we're dealing with today are parabolas, but all this is the same. I forgot that we'd done this before. Yay. Now, these are a little more involved than absolute value because we're going to get a lot more information than we did. So you have this. I'm going to pull this up and give you an example, and I'll show you everything we have to do with them. Everybody's got this written down?
Mm-hmm.
Okay. So here's your first example. We'll do f of x equals x minus 4 quantity squared plus 5. The things we're going to do, we're going to graph it. We're going to state the vertex. And this is going to be true for every single problem that you do. And I actually looked at your test before your class to see what I asked for on your test. That way we're getting in the habit of doing it every time. We're going to, I already forgot, we're going to state the axis of symmetry. We're going to state the domain and range. And then the last thing we're going to do is state if the vertex is a max or a min. So we're going to do this for each problem. But you're going to see that there's a lot of things that are exactly the same for every single problem. So let's talk about this graph. I'm first going to graph the parent function. Its vertex is at 0, 0, and this is what it looks like.
Okay. Is there no A?
There is an A, but we don't write it. So what number's there that we don't write? 1. I heard somebody say it. So if there's a 1, it doesn't change it wider or narrower. It's like rise over run, 1 over 1. So what does this minus 4 tell us? Remember, it's opposite on the inside.
I'm gonna go right 4.
Okay, so we're going right 4. And then the plus 5?
Up 5.
Up 5. So I am taking my vertex right 4 and up 5. So what is my new vertex?
4, 5.
4, 5. So you would come over here and you would list 4, 5 as my vertex. Now, the graph itself doesn't change its width because the A term is just 1. It's positive, so that means it's going to be a smiley face. So I can just sketch this graph. We're not getting exact with it anyway. Yep.
So if it was a negative, there'd be a negative sign before the parentheses?
Yep.
Okay, and
'Cause that's where A
That's
is.
just how you tell is if there's a negative sign before the parentheses. or not.
If the A is negative. The A is always in front of the parentheses. Okay, let's fill in this other stuff. Let's start with number 5, though, because that makes sense to start with the last one. It's actually the easiest one. When I ask if it's a min or a max, I'm asking about this vertex here. Is it the highest point of the graph, the maximum, or is it the lowest point on the graph, the minimum? Look at the point, the vertex.
Low.
It is the lowest point,
Yes.
so what does that make us?
Min.
The minimum. It's the lowest point,
Okay.
not
So
max.
If it's
I
negative,
thought
it's
you
max.
meant,
If it's
like,
positive,
the
it's
graph itself, like the highest.
Yeah. That's,
The highest point would be like if it's upside down.
Yeah, I was.
so if it's
You go
negative,
backwards?
then it's
No.
max. If it's positive, it's min.
Correct. If it's the top, then it's going to be the maximum. If it's the bottom, then it's going to be the minimum. Okay? So this is minimum, so we would circle minimum or write minimum on your test. And then axis of symmetry, something we haven't done yet. Huh?
4.
Well, we have to, what is 4? The axis of symmetry is this line that goes straight up and down, that if I graphed well, it would be right in the middle of the graph. And you have to say what this axis is. So 4 is the right number, but what equals 4? What is this line up, straight up and down?
What?
X.
equals 4.
X equals 4. So the axis of symmetry is always going to be X equals because it's always going to be a line straight up and down. And it's always going to be x equals the x of your vertex.
Oh, got it.
Okay, because you're going to go right through the vertex.
Wait, so x is 4, like if you put that in the equation?
You don't have to write an equation. You just have to say what the axis of symmetry is. Which x equals 4 is the line straight up and down. Okay, now domain and range. Domain is super easy. Domain, does it deal with the x values or the y values?
X.
X values. So I'm going to look at this graph and say, where is this graph? Where does it have x's? It's a parabola that's going up forever, so it's going to cover every x. The domain on every parabola is negative infinity to positive infinity, because it will always have all of the x values. Okay? So for domain, I'm going to write negative infinity up to positive infinity, just like that.
What?
Or you can say all real numbers. The range are all of the y's. So what's, for the blue graph, where's the first time I have a y value? If I start here at negative infinity.
Not yet. Oh, ding.
Okay, what is this y value?
5.
5. So this graph, the range is going to go from 5 all the way to infinity. So the range would go from 5 up to infinity.
Doesn't seem too difficult.
And that's all the information we need.
So 5 to infinity ranges?
Yep.
So it'll always be something to infinity?
No, if it's flipped upside down, it's going to go negative infinity up to whatever that top y is. We'll do one here in a minute. Okay, not bad for our first one? Ready for some more?
Let's do it.
Okay, let me give you another one. This time I want you guys to try to graph this one on your own, and then we'll fill in everything else. So the equation I have is f of x equals 3, parentheses, x minus 3 squared. Actually, I'm going to change that 3. Oh, it's fine. And then minus 2. Here's my original. Why don't you guys try to graph it on your own, and then we'll fill in everything else together. Okay, what does this minus 3 in here tell me to do?
To the right.
To the right 3. And what does this minus 2 outside tell me to do? Down 2. So what is my new vertex?
3, negative 2.
3, negative 2. So on vertex, you would write 3, comma, negative 2. Then what does this 3 out front tell us? Is it a smiley face or a frowny face? Smiley. And if it's 3, that means I'm rising 3 but running 1. What does that do to the graph? Makes it narrower. Okay? We're not going to try to plot that exactly. We're just going to make it look narrower than your original, because then that shows me that you're saying it's supposed to be narrower. So what is my axis of symmetry here? X equals 3. And then we've got our domain. What's our domain of this graph?
Negative, infinity, infinity.
Okay. By the end, you guys get sick of saying domain. So it's always going to be negative infinity, positive infinity. Please don't miss that on your test. Yes?
So I'm a little behind, but it's 3, negative 2, right?
Uh-huh.
So you go over 3?
Over 3, down 2.
Okay, I just didn't see negative 2 tick mark, so I didn't know why.
Oh, it's gone through this one. 1, 2, 3.
Oh.
It was there. Okay, the range. What is the lowest y value we have on this graph?
Lowest y value.
The lowest y value. So if I look from down here up, what's the lowest y value?
-2.
-2. So -2 starts our range. And the range goes up to infinity. Just two.
I wasn't very happy.
Okay.
You messed up.
I did. Okay, I'll fix it in just a minute. Just leave those out. Let me figure out what I did. Okay, and then is this vertex here a min or a max? Is it the highest point or the lowest point?
It's a min.
Minimum. How is that? Not too bad? If it's the lowest point. Okay, let's do one you guys are going to do from beginning to end now on your own, and then I'll do one more with you, and then I'll give you your assignment for today. So I have for this one, f of x equals 1/2 x plus 1 minus 3.
We have to graph.
You need to do everything. You've got a graph. Over here, I want you to state the vertex, the axis of symmetry, the domain, the range, and min or max. You guys do everything. What did I do? Okay, so this plus 1 here tells me to go, well, here's my original. Let's start with that. So the plus 1 tells me to do what?
Negative left one.
So left 1. And then minus 3 tells me to go down 3. So my vertex is going left 1 and down 3. So my new vertex should be -1, -3. This 1/2, what does it do to the graph? First of all, is it smiley or frowny?
Smiley.
Smiley. And then it's up 1 and out 2, so that means it's wider.
So why is this different than absolute value?
Well, we've got more that we do with it. Absolute value we just graphed.
Almost the exact. Except it's different.
All the shifts are the same. The shifts are always going to be the same.
Okay.
I said it's more
Why
involved
is this one curved?
because it's a different function. Absolute value is its own function. Quadratic is its own
But is
function.
it still touching the same points?
No, no. Absolute value has constant slopes. This has ever-changing slopes because it's a different function. Every function looks different. This is this shape.
So are we going to be able to actually draw those where they're supposed to be? Or not?
When we graph them in standard form, they'll be a little more exact because we're going to find y-intercept and everything else. Okay, so axis of symmetry is x equals what?
-1.
Okay, attention up here, please. Thanks so much. X equals -1. Domain is going to be what? Negative to positive. What's the lowest y value? -3. So we go from -3 up to what? Infinity. And is this a min or a max?
Min.
It's a minimum. Because you include -3. Okay, let's do one more. This time I'm going to flip it over.
Whoa.
So our last one, before I let you guys go on your own work, is going to be this one. Y equals -2 times x minus 1 squared minus 4. So here's our original. What does our shift tell us to do here?
No, that's
The random.
Right 1 and down 4. So for my new graph, I'm going to go right 1 and down 4. And then it's, oops, keep it so I can see it. Then I have a negative 2 here. So the negative 2 does two things. What's the first thing it does?
Makes it
A frowny face. It's going to flip it over. And then the 2 part, if I think of it as slope, it's like down 2 and out 1. So it's narrower than my original. 2 makes it narrower. So my vertex here is 1, negative 4. The axis of symmetry is x equals what?
1.
X equals 1. What's my domain?
Negative infinity.
Okay, negative infinity, positive infinity. Okay, range is different, so I want everybody's attention on range, because this is a different one than what we did. Every time we do with range, we start at like the most negative y value. So since these arrows are going down, what's the most negative y value? Negative infinity. So in this case, I'm going to start with negative infinity, and I'm going to go up to the highest point, which is negative 4. So this range goes negative infinity up to negative 4. So that makes this point a min or a max? Maximum. Okay? How was that?
How do you know if it's narrow? I guess I don't know. I'm confused.
We look at that number and we think of it like slope. So this would have gone down 2 and out 1. So you're going down more than you go out. So that would make it a narrower graph. If it was 1 over 2, you'd go down 1 and out 2. So it would make it a wider graph.
Yeah.
But it's not a real slope. If anybody ever asks, it's not a real slope.
It's not a real slope.
Because the slope on parabolas are always changing. Those of you that are going to calculus will find that out in calculus.
Yeah.
Okay, so here are the problems I want you to work on. I want you to ask questions as you go. Okay, please stop talking while I'm talking. This is not that hard today. I'm going to change the directions on some. Okay, so you're going to go page 199. 15 to 22, you're going to graph each. You don't have to state everything that it stated. And then 29 to 34, I want you to graph, do the axis of symmetry. Actually, I want you to do everything. Domain and range, min or max.
And vertex.
Yeah. So on the first part, all you have to do is graph, which is nice.
What number?
107.